Okay, so today in this video I'm going to talk about isotopes. So I kind of sort of alluded to this. This picks up from all the things we just talked about. So as I mentioned before, an atom of a given element has to have a certain number of protons. And we can figure out how many protons that is by looking at the atomic number on the periodic table. So we know, for example, that carbon must have 6 protons, and we know that oxygen must have 8, and so on and so forth. However, there's no such limitation. Oh, in neutral atoms, protons and electrons have to be equal. I'll talk about non-neutral atoms in a little bit. But really, there's no such stipulation on the number of neutrons. Number of neutrons can fluctuate. And in fact, for any given element, the number of neutrons can vary over a small range. An example I used before when we talked about symbols, you could have carbon-12 and carbon-14. Now, both of these have 6 protons, right? But this one, carbon-12, has 6 neutrons, and carbon-14 has 8 neutrons. So we have these 2 different variations on carbon, right? And they're both carbon because they both contain 6 protons. It's the number of neutrons doesn't change what kind of element it is. So there are 3 types of hydrogen known to exist. Just as another example, hydrogen with 1 proton and no neutrons, right? And so that would be H1, right? Because its atomic number would be 1 for the 1 proton, and its mass number would be 1 because 1 plus 0 is 1. And then we have the next one, 1 proton and 1 neutron, that's H2, and then we have H3 for 2 neutrons. Now these are all, again, they're all hydrogen because they all have 1 proton. But the number of neutrons changes changes their mass number, which also changes how heavy they are, right? Now, an isotope is, now all 3 of these 3 examples, these are isotopes of hydrogen. So it's important to understand that the chemical properties of hydrogen are going to be the same because the number of protons and therefore the number of electrons are going to be the same. But the number of neutrons changes the mass of it, right? So we have 3 different isotopes. So those 3 isotopes, H1, H2, and H3, right? So an isotopes are atoms of the same element that definitionally must have the same number of protons, but different numbers of neutrons. So most elements have a couple different isotopes. For example, chlorine has, there's chlorine 35 and there's chlorine 37, right? So chlorine 35, since chlorine has 17 protons, if you take 35 minus 17, the remaining must be neutrons, must be 18, right? And 37 minus 17 is, of course, 20. So this one has 18 neutrons, this one has 20 neutrons, right? So those are 2 different isotopes. And they only differ, isotopes only differ by the number of neutrons. Now, a word about the use of the word isotope. I think there's this tendency that people want to say, there's I guess a couple words about it. The most abundant, the most common is H1. So people have this tendency to want to say, well, H2 and H3, this is hydrogen and these 2 are isotopes, which isn't really accurate. They're all 3 isotopes. Isotopes are just ways of indicating atoms of a particular mass number, right? So an isotope of an element is just referring to atoms with that particular mass number. So certain mass numbers are stable, some are not. The not stable ones are radioactive. I referenced the other day iodine 131, which is radioactive, right? But other iodine isotopes are not necessarily. Each isotope, and I should also point out something else. The periodic table doesn't give any indication about how many neutrons there are or which isotopes even exist. So you wouldn't know from looking at hydrogen that there are 3 different isotopes, and they are hydrogen 1, 2, and 3. Again, I'm not talking about this number yet. This number tells you nothing right now. Ignore these numbers down here. You would have no way of knowing that phosphorus only has 1 isotope. So from the periodic table, so far, all we can tell is what the element is and how many protons it has, and therefore how many electrons it will have in a neutral element. You need to be given the mass number if you want to know how many neutrons it has. Did I say neutrons before? We know how many protons it has, and therefore how many electrons it has in a neutral element. Make sure I say that right. And therefore, we know those two, but we don't know necessarily how many neutrons there will be. You have to be given the mass number. So each isotope has what's called a percent abundance. So the percent abundance is the percentage of atoms that have that mass number. So, for example, of the two naturally occurring isotopes of chlorine, chlorine-35 has a percent abundance of 75.53, and chlorine-37 is 24.47, meaning that in any natural sample of chlorine, 75.53% of them are going to be chlorine-35, and 24.47% of them are going to be chlorine-37. So we have a mixture of the two. And that's really, for just talking about isotopes, that's all I really need to say. So just know that different isotopes, we indicate each isotope by its mass number. So if I say, iron 56, I'm referring to iron 56, right? That's telling me the specific isotope. So that is referring to atoms of that element that have that many, or that mass number.